Hello everyone and welcome back to our introduction to Kotlin. Today we will be looking at the syntax, and I've spread it across two major parts. The first part would be covers the following: our basic types, local variables, functions, control flow, strings and string templates, ranges, type checks and casts, a little bit more about null safety and some comments. And I've then kind of partition that out into smaller parts. So today in our part one, we will just talk about basic types and local variables, val and var. Now you would have probably covered some of this in that first lab, so this is kind of like just to reinforce some of the concepts and principles you would have looked at in the lab. So to begin with, just to look at our basic types, which kind of falls under numbers, characters and booleans. To recap, in Kotlin, everything is an object in the sense that we can call member functions and properties on any variable. So again, we kind of touched on this in earlier sections. Different to Java, which had objects and basic types, everything in Kotlin is types. So everything has properties as well as its behavior. So we can call member functions on those particular variables. Okay. To talk a little bit about numbers, it's kind of more just for informational purposes really, but we have these different types. So we have double, float, long, int, short and byte, and you can see there the bit width, basically how much space it takes up. In terms of defining those types, we can, as we would have seen already, we can explicitly define a numeric type. So if you can see here, we're saying val, again they're all val, we'll cover that now in a minute, but we can say val double number, just to highlight there for a second. Here we are up here, val double number, and assigning it a value of 100.45. For argument's sake, this one here, we're saying an int number, explicitly specifying it as an int, giving it a value of 100. And we can do the same with a byte, a short, and all the rest of it. Okay, so that's an example of how to explicitly define our numeric type. And the same goes for all the other variables, as we'll cover in due course, to the different types. We can also, as we've seen before, infer the type. So we could say their double number is assigned directly 100.45, no mention of a type at all, but the compiler, Kotlin compiler, is able to infer what type double number would be based on the value we've assigned it. If you notice there, for a float, we can say, just click it there now, sorry. We can do the little f, small f for float. We can say for long, it's a big L. And we'll see some other kind of characters that we can use to make the identifying of the value and the number a little bit easier in the next couple of slides. But again, this is just how we kind of infer the type. Either or is fine if you want. Just to go back to it there for a second, it's more than acceptable to explicitly declare the type. So maybe if you want to just be kind of explicit about it yourself, and in when you're revisiting your code or whatever, but it's very common to just do the following, especially when we're kind of assigning and we know we want to give it a value to begin with. A little bit more about the type inference there. If we had the following, and you would have done something like this in your in that first lab. So if you can see here, down here, we are using a println to just display to the screen. For example, the first one there, double number type is, and then we can append the calling the .java class property of our double number to get the actual type that it is. So you can see here and what the Java class equivalent will be, so to speak. So if you look over here, you can see that we have double number type is double, float number type is float. Likewise for long number, int, short, number, and a byte number. So we can just see that each particular value, the hundreds over here, are seen as all ints over there, and that's kind of relevant for the next couple of slides that we look at. So what you can also do is you can use underscores to make number constants more readable. So if you see up the top here, we're saying declaring 3 variables here, 3 vals, 1,000,000, 3,000, and a credit card number. But if you notice, the 1,000,000, we're saying 1_000 underscore 000. And again, that's perfectly acceptable to do in Kotlin to just make it a little bit more readable, because especially if you look at the credit card number there, that will be kind of hard to decipher as one big massive number. But we can intersperse underscores to make it a little bit more readable, and it still gets picked up as the number. So if you can see down in the bottom there, in our console, if we were to print out 1,000,000 and the type is 1,000,000.java class, or the next one 3,000.java class, or the credit card.java class, it tells us what those particular types are. So that credit card number would actually be of type long there, as you can see getting printed out. Okay. Some other points of note when dealing with numbers and explicit conversions, right? In Kotlin, there are no implicit widening conversions for numbers, i.e. smaller types, for example, or byte, are not subtypes of bigger ones, e.g. int. Back in Java, you could kind of cast numbers, you could convert ones to others just by a little bit of typecasting. That doesn't really happen in Kotlin. Okay, so smaller types are not implicitly converted to bigger types. A little example here, we have our val byte number explicitly specifying that it's a byte, giving it a value of 10, right? But if we then try and take that byte number and assign it to a val int number of type int, we'll actually get an error. That's a syntax error. You're not allowed to do that, okay? But we can use explicit conversions to widen numbers. So if you see here, here's our byte number. So a byte is assigned 10. Again, that's fine. But with our int number, we can say, take that same byte number object, invoke our member function on it called .toInt, and that's fine. That will actually convert it to an integer and allow us then to assign it to that int number. Okay. And to go into it in a little bit more detail, every number type supports the following conversions. So we have, you can see there's 2 byte, 2 short, 2 int, 2 long, 2 float, 2 double, and 2 char. So each any of the types that we need to convert between is fine, because we have each class has its own member function and has those and supports those particular functions. Okay. So again, another example there, val int number of type int, giving it a value of that byte number .toInt. We can do the same with float, the same byte number .toFloat, because each of the objects supports all those different conversions. Okay, so we can mix and match through the functions, as opposed to casting like you would have done in using Java. So to talk a little bit about characters, excuse me. So here we are, very similar to Java. So we can see there val, a char, again an inferred assignment, just giving it a value of a, whereas we have an explicit assignment with our b char, saying it's of type char. Again, big C, because they're all objects, is assigned a value b. We can then put that inside a simple function main, print that out. It's a little println there. There's our a char, our b char. Again, just identifying or invoking the .java class. Both characters getting spit out to the console there. So then you can just see it down there, down here. A, the type is char. B, the type is also char. Okay. Some more examples with Boolean types. We can say there, just assign our flag to true. Again, inferred, or if you prefer, explicit typing there, specifying that our B flag is of type Boolean and we're giving a value of false. Very similar to the last little set of slides there. We can print out A flag and B flag, and kind of append the type at the end. They're both Boolean, but if you notice there, just still that's the Java class equivalent. It still goes back to that that lowercase b Boolean type, the Java class. But again, in Kotlin, when we deal with Booleans, the big B, if we look at it up there, sorry no, see the big B up there, Boolean, specifying that it's an actual class, and we get objects then from that. In terms of escape characters, we have very similar to what we would have had taken from Java. So we have our /t, our /b, /n, /r, and then if you need some special characters like the single quote, the double quotes, the backslash, or the dollar, same as Java, you need to prefix it with a backslash if you want to show a backslash or a single quote or double quote or whatever. Little example there, we have our a flag B or a flag B flag, inferred assignment, explicit assignment, stick it inside the function there, 2 printlns. But if you notice, we have here, we're saying \n, /t, and that will then display it slightly differently to the screen. So again, if you can remember, \n is a new line, /t is a tab. So what we get at the terminal is something like the following. So we say our true and false values getting printed, but again the type is on a new line and tabbed in a few tab spaces in there. Okay, we probably won't be using that much in because obviously with Android and we'll be using our kind of our UI and our screens and activities to display what we want in the XML layouts. But from a console point of view and purely Kotlin language, if you want to try and kind of format what you're printing out to the screen a little bit better, you can use those escape characters. Okay. Okay. In terms of local variables, so we'll be seeing a lot of this. We have val and var. So again, val basically read only, var mutable. Okay. Again, just looking at some examples here. So our val, using the val keyword, so our local variables, should I say, are defined using the keyword val. They can be assigned a value only once. So as I say, once you assign it, you can't reassign the value. Okay. It is recommended to use vals wherever possible, but obviously that may not always be the case, and that's where the var variable comes in. But in this example here, inside our function main, we have our val a explicitly defined as an int, giving it a value of 1. Then we're saying val b, an inferred declaration of a value of 2. Then we're declaring val c of type int, right? And that's okay, because if you can remember back, we can use one or the other. We just couldn't say val c on its own. We have to either give it a value or specify its type. We can then say in this example here, c is assigned a value of 3, and if you notice there, the little $sign, we will cover this in a little bit more detail in later on, but just highlight it there. See that you can have the $a, and I show it here again, the $c. That's a very neat way of accessing the particular variable. So in this example here, what we're saying is we're going to print out to the screen a with the assigned operator, and then $a. So whatever the value of a happens to be will be printed out there. It avoids us having to mix and match and embed a plus, if you can remember how you would have had to do it in Java, and then the variable that we want. So this is all, if you see there, it's all inside a string. Our a with the $a, b for $b, and then c is assigned $c. And what we get printed out to the screen is what we were expecting. The a is assigned 1, b is assigned 2, c is assigned 3. So that's all fine, that's grand. All right, all just declared and assigned once, and in the values used. Values have not been reassigned in this instance. Now, if we try and reassign the value c, we can maybe give it a value 4, for example, we will get an actual syntax error, compile time error, something along the lines of val cannot be reassigned. So that's fairly self-explanatory there. So as a rule, if you know you're only going to need to give it a value once and just kind of reuse that value, it's recommended to use the val declaration. But obviously with applications, and we need to be where values will regularly change, that's obviously very restrictive. So what we can do is we can use a var declaration, which allows us to change the value. So variables that can be reassigned use the var keyword. So here in this example, we have var x is assigned 5, again an inferred integer declaration. We can then say x plus assign 1, so just kind of like accumulate or add 1 to the value x, and that's fine. And then we can print it out to the screen. We have our println x is assigned $x, which is fine. Okay. We can also reassign. We can say in this example here, x is assigned 10, which is perfectly acceptable. Whereas if that had been declared val, that again would be another error. And we'd even get an error on the plus assigned as well when we try to add 1 to the value of x. If that was a val, that itself would be an error, because again we're trying to change the value of x after it's been assigned, which isn't allowed with vals but is allowed with vars. So that's the kind of the main difference between val and var. Use val wherever you can because it allows the compiler to optimize the space and all the rest of it, but obviously you may need to use vars instead. Okay, some references there for you. A lot of them there on the official sites. Some other links there are quite useful, and that concludes that small little section. Again, it was only just looking at as basic variables and our val and var and the basic types. We will look at a lot more in the next sections, and in part 2 we will delve into classes and member functions and get into kind of the real nuts and bolts of the language. But for the moment, that kind of concludes that part, and I will see you again soon. Okay, bye bye. Okay, so welcome to part 2 of our introduction to the Kotlin syntax, part 1.2, and in this section we will be looking at the following: functions and control flow. So again, stuff that our if, when, form, while, a lot of stuff that you'll be familiar with already. The syntax will look very familiar, but then we'll obviously look at the Kotlin way to implement it, and it could be a lot neater, a lot more concise. Again, one of the big advantages of using Kotlin over Java. So to firstly look at functions, we'll break that down into just looking at parameters, return types, an expression body, and sometimes we need an inferred return type. And again, it's a nice little feature within the language itself. So just look at the first example here. We have parameters and return types. We have our function here having 2 int parameters with an int return type. So if you see it there, we're saying our function sum. This is how we declare. Okay, so we have our a full colon int comma b full colon int. So that's specifying that this function sum takes 2 integers called a and b, and from our point of view returns an integer. And again, if we look at it here, return a plus b. Okay, how we use it is in our function main. We can a simple print. We can say sum of 3 and 5 is, and we can pass in the function into that println statement, 2 actual values, 3 and 5. So obviously 3 and 5 get passed in, added together, and we get an overall result. Sum of 3 and 5 is 8. Okay, pretty straightforward. So the point to note here is that when we want to return a value from our Kotlin function, we can explicitly say what the return type is. In this example, it's an int. Okay. What we can also do is we can use inferred return types, which is kind of cool. So the same example there now. So function sum again takes the 2 parameters, a and b, both of integers, but this time we're saying is assigned a plus b. We've actually gotten rid of the whole body of the function altogether. No curly brackets, no keyword return. We're just saying is assigned a plus b, so that's an inferred return type. So again, it obviously reduces down the size of the function. How we use it, is as follows. So inside our println, we can either use it the kind of the regular way and our plus, and then we can say, like in the Java days, plus sum and then pass in our values, or we can use our $sign again, but just note that if you're going to use the $sign, it needs to have your curly braces. So just to show you that again, see there, we're saying $sign, curly brace, the function, close the curly brace, all inside just one big string. Okay, and that's the advantage of using that dollar, that we don't have to use a plus, and if you extrapolate that out, if we had a lot of different functions, different variables, we get quite messy and quite cumbersome. And again, just the result is as follows. There are sum of 19 and 23 is 42. Okay, so the function sum, this is with an expression body and inferred return type, which is quite neat. Okay. What if you don't have any return data though? So this is this simple example here. So if we just highlight it there for you. Here's our function, very simple function, just calling a print sum. Again, takes an A and B, but just prints the values to and a result to the screen. So you can see here, sum of $A and $B is, again, look, dollar and the actual expression inside the curly brackets, A plus B. But because it's not returning a value, we signify that with the unit type. It's kind of a generic type, pardon the pun, in Kotlin. But a lot of the time, the unit return type can be omitted. Okay, so we can actually do the following. We can actually we can actually use the same function and just leave out the full colon unit altogether. And again, that's generally the way it happens in Kotlin. It's just that the way the language has been created, types of, it's kind of like our void, you know, when you were dealing with a void, the void type, that it's still a type, so it has to be specified. Okay, but most of the time we can leave it out. So if we have a return type, we can actually even infer it, explicitly specified, or if there's no return type, we can leave it out altogether. So to talk a little bit about control flow, so we'll focus on our if, when, for, and while. Again, all taken straight from, well, some of them anyway, for and while taken straight from Java. Okay, so we start with our if. So we have this is the traditional way to write ifs. This is what we're familiar with. This is essentially a Java if statement in there. So in this example here, our function max of, again, taking two parameters, A and B, returning an int. Simple comparison. If A is greater than B, return A. Otherwise, else, return B. Very simple, very straightforward. In a function main, we could embed it using our $sign again. So we could say something like this down here. Dollar, with our curly brackets, call the function max of and pass in our two values as 0 and 42, and obviously we get back 42 as an answer down here. So there's our max. Okay, so again, that's what you will be familiar with coming from Java. You can still do it that way in Kotlin, there's no problem at all, but we can actually write these much more concisely, so it's kind of recommended to do it the Kotlin way. Okay, which we'll now look at now in the next couple of slides. Okay. However, in Kotlin, if is an expression, i.e. it returns a value. So therefore, there's no ternary operator. So if you remember that question mark, whatever it is, and with the exclamation mark, this one here. If there was just basically two clauses, your if then else clause, so that's actually gone in Kotlin, because ordinary if works just fine in that particular role. Okay, so just kind of be aware of that you still have to, well, to begin with, you still have to write it kind of like the basic ifs, but we'll see now in a minute we can actually condense that down. Okay, so that's your kind of like your traditional if else. Okay. If we want to use if as an expression, we can say something like the following. So we could begin, or we can take this function here, okay, which is our standard if and our basic if clause there, a greater than b, return a, else return b, and we can actually condense that down to the following. We can say, here's our function, max of with our a and b is assigned the if statement. So if a is greater than b, a else b. So again, nice little reduction there, but still results in the same thing getting returned, whether it's a or whether it's b. So again, there's our function main, same as before, and the result obviously is the same. So very, very kind of neat way to condense down that a simple if else. Okay. If we want to look at some examples without using functions, so here we have the first two examples use if as a statement, and the last example uses if as an expression. Okay, so if we look at the example up here, so again, just to highlight it there, so we're saying our var max is assigned a, so for argument's sake a has some previous value, and we can assign that because it is max is declared as a var, and then we say if a greater than b, max is assigned b. So again, kind of fairly straightforward, kind of similar to what you would have had from your Java days. But we can then say, down here we can declare our max as an int, and then we can assign it later on. So if a is greater than b, so if just see a look at it there, we can say if a is greater than b, max is assigned a, else max is assigned b. But as an expression, we reduce it down to one line. There it is there. We can say val max is assigned if a greater than b, a else b, and then depending on how this condition, depending on how this evaluates, will determine whether a or b gets assigned to max. So again, you get, if we compare this, all that, to this, using the Kotlin approach is obviously a lot neater, a lot more concise. Okay. To talk a little bit more about if branches can be blocks also, and the last expression is the value of the block. So you can in this example here, we're saying our val max, using it then as an expression, but we have actual blocks inside the expression. Okay, so as well as just getting a value, we can cause something to happen as well. So in this example, if a is greater than b, we choose a and actually return a, otherwise we print out choose b and we return b. So in general, if you're using if as an expression rather than a statement, so for example returning its value as is in the example above, or assigning it to a variable, the expression is required to have an else branch. Okay, that's just some of the requirements when you're using it as an expression as opposed to just your standard statement. Okay, so just kind of a couple of points to note there. Looking at when, so this is new in Kotlin and it replaces the switch in Java, and using our lambdas and kind of the latest syntax makes for very neat coding. Okay, if you look at this here, so example here, we're saying just this one here. Okay, we're creating our value, declaring it, x, assigning it a value of 10, so an inferred value that it's of type int, and then we can use our when on the x value, and in this example here, when it's 1, execute, or that's like an anonymous block, an expression there, print x is 1. If it's 2, print out x is 2. And you can actually do ranges. We will look at ranges in a bit more detail later on, but for in this little example, we can actually say if that value x is between 3 and 10, invoke that little statement there, print x is between 3 and 10. So again, very neat, very concise, and is a lot easier to add to if you compare that to what the equivalent of what a switch statement would be. And you can see down there below just what the result that would be at the display to the console. Okay, depending on what the value happens to be. Okay, so again, very nice addition to the language. Another little example, when our particular x, so depending on what x happens to be, if we have our 1, our 2, that'll execute depending on if that's the value. Otherwise, right, as a note that this is inside a block, so we can actually carry out more than one line of code. The previous example there, just to go back to it again, very simple example, it was just a one-liner, right? But you can actually embed blocks if you want to also. So in this example here, we're just saying if it equates to that, if x was 3 for argument's sake, the else block would get executed, so we can print x is neither 1 nor 2. So you can mix and match there as well. Just to look at some more examples. So in this one here, the first one. So this example up here. Okay. We have branch conditions may be combined with a comma. So in the last couple of slides, we saw it was a particular range. In this example, we're looking for specific values. So we can say 0, 1, 2, 3, whatever it might be, if it happens to match with any of those numbers. Or we can have our kind of else clause within that, when else print something else. In this example, print otherwise. In the second example here, we can use arbitrary expressions, so not only constants, right, as branch conditions. So we have there, we're saying when x, so the first thing we do is that's inside the block there, we're checking parse int, passing in s as a parameter, so that would print s encodes x, and otherwise we can actually say otherwise print s does not encode x. Okay. In the last example there, we can also check a value for being in or not in. So this is a new addition to the language again, a particular range or a collection. So here we have when x, if x happens to be in the range 1 to 10, so 1.10, we will execute that statement. So print x is in the range. If in invalid numbers, so that valid numbers could be a list, could be an array list, whatever, of particular numbers. If that is the case, so that all happens behind the scenes, that whatever the value x happens to be will be compared individually to each element in that range, in that collection. Right, this particular example is a collection, and would print then obviously x is valid. Or you can do the opposite there. You can say if it's not in or not between, in this example 10.20, then it'll print that x is outside the range. Finally there, if it's none of the above, we get our little else clause, else print none of the above. So again, very neat, very concise. And if you try and compare that to or how you would have had to do that using switch statements and using if statements, would probably take a good few more lines of code. Okay, so nice little, again, features in the language. Sorry, no. Another little bit about when. So another possibility is to check that a value is or isn't or not is of a particular type. And note that due to smart casts, and we cover that in more detail, you can access the methods and properties of the type without any extra checks. So we'll talk about that smart cast. I'll talk a little bit about it now. We'll look at it in a lot more detail later on. But we'll just look at the example first. So here we're saying, this example here, this function here, okay, we have a function called hasPrefix. This is another new type, as we're seeing there now. It can be anything. So you specify the type as any. So that there's a lot of flexibility in that particular function. So the value x can be anything. And then we're actually using assigning a when as an expression. Okay. So we use our when clause there. So when x, so if it's a string, x that starts with the prefix, so that starts with is a function that belongs to the string class. Okay, and then otherwise just kind of return or assign false. Now the key here is referring back to that smart casts. X could be anything, right? But if it's picked up as a string, the Kotlin compiler knows it's a string and doesn't need to do any extra checks, any extra casting. Straight away knows X is a string and can invoke the dot starts with function and then return that as the value, and that gets assigned. Whereas we have the else part, then it's just false. Back in the Java days, you wouldn't be able to do anything like that. There'd be a lot of checks having to go on. Then you'd have to cast it. Once you find out what type it actually is, you'd have to cast it to another type. So this is a nice, again, another nice addition to the language. Okay, just to continue on there. Sorry. Just to continue on a little bit more about the when. So when can also be used as a replacement for an if-else chain. Okay, so if no argument is supplied, the branch conditions are simply Boolean expressions and a branch is executed when its condition is true. So we're not actually comparing against anything at all. Okay, so if we look at here, right, there's just our when on its own. We're not comparing against a value. We're just going into the when block itself, and if x dot is odd, x dot is even, assuming now that x has been obviously assigned previously and has a value, it will check here. These are other functions that belong to these the numbers. This case here, again tying into our smart casts. If x happens to be a number and it happens to be dot is it is an odd number, we will print x is odd. Otherwise, if it happens to be even, x is even. And if it's not a number, maybe it's a string, some other object, whatever else, we will print x is funny. So there's no extra conversions having to go on. It's not going to crash. It's not going to bomb out. It's all done. Kotlin looks after all those checks automatically behind the scenes. Okay, and so you don't have to. Which again, very nice. A little bit more about it there, looking at slightly little mixing and matching all kinds of different things here. So here we'll have a function called describe. Again, takes, just highlight it there if you know, takes an any type object, so again just called obj, is going to return a string, and then our expression then is wrapped up inside the when clause. So that's that there. So if we trace through it, so again, with our object could be anything. We'll check it now in the program in a minute and see how it works inside the function. But if that object happens to be a value 1, we'll return the string 1. If it's text hello, we get greeting. If it is a long type, we do that. If it's not a string type, we do that. Otherwise, we do that. So there's a lot going on in there in a very short number of lines of code. In terms of inside the function itself, we can see here just some basic println statements, calling the function, passing in there, look, describe, and then it's the value 1, describe the text hello, a long value of 1,000, the number 2 of an integer, and another string just called other. And you can see there was the values there. Initially we get 1 printed out because that's what was expected. There we are, there's that one there, sorry. The next one, it was a string. So yeah, we get greeting. It actually matches, sorry, with hello. That's why we get it there. The next one is the type of long, which it is. So we get long printed out. The next one was the number 2. So 2 doesn't match with anything. So it matches with not a string, so it's not a string, so that's why we get that printed there. And then finally the last one is just a text other, which doesn't match with anything, not the number, not that text, is long, it's not a long, it is a string, so we're not going to match with that. So the only other option is this one here, unknown, and that's what we get printed out there. So again, just kind of demonstrating the different features and the different way we can mix and match some of this control flow. I can't imagine how you might use that in actual real life, but it just demonstrates what you can do, and if you need to be able to compare different types, check to see different values, and wrap it all up in some nice, very concise clauses. Okay. we have, sorry, no, there we go. In terms of our for loops, so again, similar to the later syntax of Java. So the for loop iterates through anything that provides an iterator. If you can remember back, an iterator, it's like, if you can remember, it's like a pointer into your collection, right, or your list of data. And it is similar to the for each loop in Java. So if you can remember from your Java days, we could say something like for item in collection, and then just print out the item. So that would loop through every element in that particular collection, and we can do something with it. In this example here, it'd be a simple print. So if we look at our function main down here, so we have let's do our flashlight again. So we have our items list of, okay. We say val items is assigned list of there, so we implicitly kind of convert item into a list. Items, should I say, sorry, just has 3 strings, apple, banana, and kiwi fruit, and then we can use that for item in items and just print it out to the screen, and you can see down there we get our apple, banana, and kiwi fruit printed out to the screen. So again, very similar to what you would be familiar with in Java. Now, what you can also do, right, if you want to iterate through an array or a list with an index, right, you can actually do it this way. So again, here we have our, just highlighted for you there. So we have our same list. So we're using our list of function to take that, convert that, those 3 variables, apple, banana, and kiwi fruit, into our items. So we get a list of items, and we can say for index, which is kind of like a number, in items.indices, we can say println item at $index is, and then we can access the value itself, dollar open bracket, the curly brackets, items, and use the index like the old school array, so to speak. Use the index to get in at each element of what items happens to be. And the beauty there is, if we go back again, if we look at the previous example, sorry, no, just go back to that slide again. In this example here, all we are doing is printing out the item. So we're just getting at the data, okay? But if you need to get at the index as well, you can do that through the items.indices. So here we're getting to print out both the data and the index. So for kind of going forward, if you need to be able to locate the individual index for maybe updating, for maybe deleting or removing or whatever, you may need access to not just the data itself, but the index also, and then that's a way to do it, okay? What we also have there is, alternatively, you can use the with index library function. So again, here we are now just creating a simple array. Just here, again, val array, just our with three values, A, B, and C. And in our for loop, we're saying there just a whole lot there. We just kind of break it down for you there. If we look at the first property, so to speak, it's not just it's not one property, it's 2. We have an index comma value inside those brackets, so we're kind of like actually using 2 things to loop through this array at the one time. All right, so for index comma value in our array.with index, we're basically saying we want to iterate through our array but with the index, okay? And we can say there println the element at $index is $value. So you're getting to access to both the index and the value at the same time by invoking the .with index library function on your collection. In this example, our basic array. And then so what we get at the bottom there is the element at 0 is A, at 1 is B, and at 2 is C. So again, it's a kind of a neater way to do what was done on the previous slide. The result is the same. You're getting at the index and you're getting at the value, but it's just kind of like a nicer way to do it, okay? Just to look at our while and do while, so they work as usual. So you have a while x is greater than 0, we could just kind of x minus minus, or our do while, so we can kind of a val there, a val y is assigned, we just kind of get the data, and then while y is not equal to none, so we can do something. Just note there that y is visible here. In Java, right, if you can remember, right, if we declared a variable inside the loop, it wouldn't actually be accessible because technically we're outside the loop. So we might have had to declare this block or declare this and get the data first outside our while loop, and then go off and do something and get it again and compare it. Whereas that's kind of just a nice little kind of a addition in Kotlin again. Even if we declare it inside the loop, it's still accessible outside the loop. And again, just remember that with a while loop, it may or may not be executed based on the value, whereas a do while will always be executed at least once. So do whiles are kind of good for menu systems, and we will be using a do while in our console or Placemark console app. Okay. Note, Kotlin also supports traditional break and continue operators in loop. So if you need to jump out at any point within your loop, or for some reason, you can still use those breaks and continues. They're not that common anymore, but they are still supported within the language. Okay. There's the same references again from the last page, and that concludes that section. Again, we've looked we'll just quickly go back to where we are at the moment. Okay, so this is what we looked at today, and what we'll be looking at in the next section will be along these lines here: strings and all the rest of it, templates, ranges, type checks, null safety, and comments. And then in part 2 of this whole syntax introduction, we will look at our classes, maybe some interfaces, and as I said, getting into the nuts and bolts of the language itself. So other than that, thank you, and talk to you soon. Hello all, and welcome back to our introduction to Kotlin. This set of slides are slightly different in that we'll kind of take a little walk through our versions of Placemark console. So in this one this is our Placemark console version 1. Its functionality is quite basic, but it's essentially what you'll be doing in that first lab proper of just a Kotlin console app. So it won't be the full project, so to speak. We won't look at all the code, but we look at kind of the highlights, so to speak, and a walkthrough of the most important aspects of it. So the way I'm going to break it down is tied in with our theory side, and the sections that we've covered and the features that we've covered from part 1 and will cover in part 2. I will highlight where they crop up in our versions of Placemark. So as we work through the different versions of Placemark, obviously more features will come in, more of the language will come in, and then we will talk about those in later similar slides. Okay, so today, as I said, it's only about version 1, which will be quite basic, but it does touch on some of the features that we would have covered and are covering in part 1 and will cover in part 2. So what I've kind of highlighted today, what we kind of will look at, are those basic types, local variables, some basic functions. We have control flow, we have some string variables, and then we have a quick look at null safety and how we kind of trap that. And there's some nice functions there to use that we can do that. Okay. Because this is version 1, it's very simple, it's very basic. There's no classes yet, we've no data classes, there's no collections. So we will get to those in due course. Okay. So to begin with, if we look at our project structure here, it's very, very basic. We have essentially one package with one file, and I stressed file, inside that package. There's no classes yet, so all we're doing is writing a few functions that we will call inside other functions. So when you will be working through the lab, I think I highlight that it makes sure that it is a file that you create and not a separate class. Okay, again, we will get the classes later. For the moment, we're kind of starting off small, and we will build it up as we go through the weeks. Okay, and the different versions of our Placemark console app. Sorry, no. To look at in a little bit more detail, right? As I said, we have some limited features. Okay, so you can see it there. We just kind of have a logger reference there that we just kind of print messages to the console, essentially to our log catch, should I say, sorry. Basic print in there. I have a collapse at the moment, but we will have that's our kind of control flow. You can see there's the bones of a do while, and we have 4 other functions there. We have our function main, 4 other functions. We have our menu function, which we will use to obviously display the menu, and ultimately we will have our add, update and list placemark functions. They're trivial at the moment, really. They're a simple print statement just to get the functionality up and running, and just to kind of confirm that yes, our logic is working correctly, so that when we choose an option we get printed and notified that yes, we've chosen the right option, and that's kind of like the purpose for that. So similar to that K00 lab, this first lab will be pretty straightforward also. Okay, but to look at it in a bit more detail, to look at it firstly in terms of our basic types and variables, this is where they kind of crop up. Okay, there's more in there, a few more in there, but just to highlight some specific examples. And this one here inside our function main, we have our input, right? So we have a var input variable of type int, right? Calling it input. And again, we've declared it as var because this will be changing as the user enters input, and we prompt the user, should I say, for input. That will change, so we have to declare that as a var variable. Okay, and that we'll see it in later slides. That will be used inside the do while loop. Okay. However, our logger, right, we can declare as a val, because once it's assigned, we don't need to change it again. So to try and optimize our code and help the compiler optimize our code and the resultant kind of bytecodes and all the rest of it, make them as small as possible, we declare our logger as a val, right? Here again with the type inferred, so we don't need to explicitly specify kind of Kotlin logging type. This cannot be changed after assignment. So once it's set, that's fine, and this is perfect in this particular situation. Okay, and you can see it there being used. The logger itself, we have it used inside. There we go. Look, simple logger, just launching placemark. We have it inside the do while loop when it actually when the user has exited, and it just saying kind of shutting down placemark. So when the user has exited the application, the last thing we do is just print to the console, sorry, the log cache, shutting down the placemark console app. Okay. To look at where the functions and the control flow crop up, right, in our first version, we have along these particular lines. So again, there's the main one there, function main, pretty obvious. That's the main function in our app, exactly the same as would have been back in Java. Takes a single parameter, args of type an array of strings, right? We don't actually use it in this application, but if we were running this at the command line, we could pass in parameters and arguments to that program, and that will be passed in as args, and we could access then args if we needed to inside that function, inside our function main. Okay. On top of that, we have our function menu, right, and this is the menu displayed to the user, and we're also declaring 2 var variables which will be used within the function itself. We have our var option to keep track of which option the user has kind of selected, right? And we have our input actually read in the input from the user. So if you can see it here, we have just to highlight it there now again. So here we are declaring our var option of type int, which is going to be that number, right? It's going to be 1, 2, 3 or a -1 or whatever, right? And we have the string representation, because remember, it's going to be a string that the user is typing in. Okay, even though they're actually going to type the numbers 1, 2 or 3 or whatever they type, it's still taken in, it's still accepted as a string through this read line function. Okay, and then we need to convert it, and that's why we will store it in our option variable and convert it to an int. So that's going to work out. We'll talk about it in a little bit more detail in a minute. But just to return back to this again, we're declaring our option here. Int not giving a value just yet, but we have declared it as type explicitly said it's an int, so that's okay. Here we are declaring our input string, right, and specifying that potentially it could be null. It could hold a null value, so we're specifying our question mark, mainly because the user may press return by mistake and nothing actually gets entered. So that we're talking that there'd be an empty string null value kind of been typed in there, which we need to keep track of in our little program, which we'll look at in a minute. So the menu itself prints a few options to the user, like so there, okay, and we can then read in using our read line. And again, if you notice there, this is the first time we're seeing this, we have the 2 exclamation marks. This says that again, it might be null. That's what that means, that what we're reading in could actually potentially hold a null value. So that this is allowing us to assign a potentially null value to this input variable there, which we then do a little bit of checking on. We say our option, we have an if expression, so you can see it there. Okay, so we're basically saying if that input, and we convert it, say dot to int or null, if that's not a null value and it's not empty, then we convert it. Okay, otherwise, this is purely just my own kind of keeping track of things, we're going to give it a -9 value just to give it some number that we can then return and check back from wherever that menu function was called. Okay, so that's kind of like the basic logic there inside our menu function. Okay, other functions within the application itself, our function add place mark, which again very simple at the moment, just prints you chose add place mark. Same for update place mark, same for list place marks. They're just essentially placeholders at the moment, just to get the logic up and running and just calling the functions. They don't really do anything. They will in later versions. Okay, so these functions are called based on the user's choice. As I say, very basic at the moment. We will refactor these functions in future versions of placemark, so we'll come back to those, and within add placemark we will prompt the user to enter the details. Same way with update placemark, we will have to go off and search, find the placemark they want to update, and then ask the user what do you want to change it to. And likewise with our list, we'll be able to just display them all in some kind of formatted manner to the console. Okay. In terms of our do while, right, where our menu gets called, so again we have our var input here, which is relative to just our do while, so we're using it in here, and we're calling our menu. So once the menu gets displayed, once the user enters an option, valid or otherwise, that will be returned and stored in our input variable. We then check that in our when, so we see it here, that's right, and depending on what the user has entered, 1, 2 or 3, we will call the relevant function, add place mark, update place mark, or list place marks. Likewise, we have a -1 for exiting the app, so if the user's typed -1, we're just going to jump out. Otherwise, it's going to be an invalid option. Okay, and that loop will continue while the user hasn't entered a -1. Okay, when the user does, we have another log just informing the user that the application has kind of like successfully shut down. Okay, so again, that code there, we do while loop to call our functions based on user input. We're using when and lambdas to keep our code clean and concise, and again just exits on a -1. You could really change it to anything you want, really. I decided to just pick that -1 for the purposes of demonstration. Okay, so a little bit about strings and null safety within our application, this first version. Okay, so we kind of touched on it already, but just to look at it in a little bit more detail, here we have it up there. We have a var input explicitly saying it's of type string, but we're using the question mark to signify that it can hold a null value, and we're actually giving it a null value initially also. Okay, so if our variable input is declared as a string and it's nullable, okay, so we can hold a null value. We need that question mark to assign a null value, right? It allows us to check for accidental empty values, and briefly discussed already, we have some basic validation on our input down here. So we take in our input, which again potentially could be nullable, but we can still go ahead and check that. Even if it is null, we can invoke our our functions, our checks on it. This would throw exceptions back in our Java days. If we try to potentially call, and there's your null pointer exception issue, we could, if we try to invoke a method on an object that happened to be null at the time, but that's looked after there, and so Kotlin kind of handles that. Okay, there's our kind of our null safety. If everything is okay, our input is converted, as I say, to an integer based on what the user what they've entered. If it's not, if it's something else, we still want to return a value, so we return a -9. Okay, and that's how that works there. Okay. That's a little walkthrough of that first application, that first version 1. It's very simple. It's very basic, very minimal functionality, but we will build on that over the coming weeks. Okay, and we'll gradually, when it gets quite complex and quite advanced, that's when we would kind of transition over to Android, and you will see a lot of those the classes again that we will be introducing in later versions of that placemark app. A couple of references there for you, same as before. I've kind of just copied them over, so they're all kind of the same ones. Thanks for listening, and we will talk again soon. Okay, bye.